Hello, everybody. It's my pleasure to participate in this annual meeting of Cropland Research Group. Even though we cannot yet meet with each other face by face, on behalf of the Landscape Management of Agricultural System Network, I'm going to report our activities and progresses of the network, mainly focusing on the core model of this network. I mean the CNMM-DNDC model. The CNMM-DNDC model is a hydrobiological model. It is a DNDC family member with special features such as phase distribution or 3 dimensions and customized resolutions. It is developed for all land types and inland waters, and it is designed, it is used to work as a core model for the landscape land management network of GRA. Since last meeting, we have made some progresses for the model development. In detail, we revised the model to better facilitate catchment landscape simulation through ending soil erosion processes by referring to the Rose model mechanisms, through ending the biochemical processes for inland waters, including pool, lake, and river, and through modifying the processes for forest growth by referring to the forest biochemical cycle model. Then we continued to validate the revised model version, and we also adapted the model from the Windows version to the Linux operating system version to enable regional high-resolution 3-dimension simulation. We have tried to apply the model for high-resolution 3-dimension simulations and the province or sub-province scale to evaluate the net land greenhouse gas balance. This model is also applied for water quality management of a lake downtown in a megacity in southwest China. In this application, the updated model is used by the local government to calculate the inflows of water, nitrogen, phosphorus, and sediment from all subcatchments into the surface water through high-resolution simulation of the whole lake catchment. Recently, one of our research project proposal has been granted by the National Natural Science Foundation of China. This is a 5-year research project for China UNEP Corporation. In this project, the CNMM-DNDC model is to be applied as the core model for developing the decision supporting tool to mitigate nitrous oxide emissions from cultivated upland in China and in Kenya. For the model development, we have published two research papers in international journals, and very recently we also submitted another paper. For research and capability, we propose 2 priorities for research priorities. One is to test or validate the CNMM-DNDC model applicability. We know validation of the model with the field observations in different terrestrial ecosystems, landscapes, or catchment is urgently needed. In particular, validation by worldwide observations subject to different natural conditions or management practices are substantially necessary. In this regard, GRA members and other countries or organizations are all welcome to join the validation and the applications of this model. The second priority is to further improve the model's functions. In fact, we are planning to modify the model code, source code to enable process-oriented simulations for complex cropping systems or agroforests with intercropping or interplanting features. But this plan is actually delayed due to our failures in applying for project funds. We are also plan to add a groundwater module to improve the simulation of the dynamical water balance at different scales. Also, we are plan to couple this model with an atmospheric model to enable simulations on the synergies and the trade-offs between greenhouse gas mitigation and erosion or environmental pollution control. The environmental pollution include atmospheric pollution or water pollution. For research and capability, we propose 4 priorities for capability building, capacity building. The first is to apply for cooperation research projects between China and other countries or international organizations. The second is to identify opportunities of cooperation with the other GRA research groups. The third is to apply for international students, and the last is to apply for international postdoc positions in different universities of China or the institutes of the Chinese Academy of Sciences. The following slides shows our progresses in the model, the validation of the revised model. This slide shows the validation with slope experimental and experimental plots. This for the simulation and a small catchment with very high resolution for sediment, runoff sediment, and particle nitrogen of phosphorus. And this for catchment simulation output for the catchment outlet. And this is revised validation, improved validation of ammonia volatilization from upland and respective fields. And this slide shows the validation and permafrost catchment with 3-year continuous field measurement of methane fluxes and natural fluxes, and this simulation of the whole catchment. And we also here I also showed as an example of the model application test at the provincial level. This is the simulation for our provinces in the Yangtze River watershed in central China. And the model simulation includes the outputs of different greenhouse gases fluxes and nitrogenous gas emissions and nitrogen losses by hydrological processes. Okay, thank you very much for your attention.